Hello everyone, this is part 2 of our review for exam 3. We left off with an example of a word problem with differentials. And so now we're going to just continue to plug away. Here's an example of a chain rule. Okay, now this is the situation when we have a chain rule where you can consider that you're starting with the function z. You can draw a little diagram here. And z is a function of x and y. So because it's a function of two variables, you'll be able to find the partial of z with respect to x and the partial of z with respect to y. But then x and y are directly functions of t. And so the partials, so because they're just a function of the single variable t, we could find the derivative of x with respect to t and the derivative of y with respect to t directly. And so therefore the formula, so this just basically helps us to generate the formula for the derivative of z with respect to t. And that would be, just reading the branches, you have the partial of z with respect to x times dx dt, and then plus the next branch, partial of z with respect to y, times dy dt. Okay, so try to squeeze in the partials here. Partial z with respect to x, and then I'll plug back into the formula. That's just 4x cubed, because y is held as a constant. Partial z with respect to y, that'll be negative 4y cubed, because x is held as a constant. And then dx dt directly, 5t to the fourth. Similarly, dy dt directly, 3t squared. And now we'll plug into the formula. So dz dt is partial z with respect to x was 4x cubed. Partial of x with respect to t 5t to the fourth, and then partial z with respect to y, negative 4y cubed, times the partial y with respect to t was 3t squared. But notice that the directions said to give the results in terms of t. So therefore, we're going to have to replace x and y by what they are in terms of t. So here we have 4t to the fifth is x, but that has to be cubed, times the 5t to the fourth, and then let me just make this minus 4, and y is t cubed, but that has to be cubed as well, and then times our 3t squared. So then we get, let's see, that's t to the 15th, t to the 19th, 20t to the 19th, and then minus, this would give us t to the 9th, times t squared is t to the 11th, so minus 12t to the 11th. Okay, now just for fun, let me just mention this. What you could do is you could actually replace x originally to be in terms of t, and replace y to be originally in terms of t, and then take their derivatives, and you'll certainly get the same results, and take their derivatives with respect to t. But we wanted you to show that by the chain rule. Okay, so now here's an extended chain rule. This is what we call the two-variable chain rule. And so you could draw the little tree diagram again if you like. And start with z, which is again a function of x and y. But then we have both x and y are functions of two other variables, u and v. So all of these branches are partial derivatives because they're all partials, they're all functions of more than one variable. So the formula for the partial of z with respect to u is going to be the partial of z with respect to x, but then times the partial of x with respect to u, and then plus the partial of z with respect to y, because see, we want to get to the u variable here. I think I cut off the other part was find the partial of z with respect to v, so you could practice that one. But we want to get to u, so partial of z with respect to x, partial of z x with respect to u, now partial of z with respect to y, partial of y with respect to u. Okay, so now we just need to find those partials. So, come over here, partial of z with respect to x is going to be, okay, here we get 2x, derivative of this y term is 0, because y is a constant. Here the derivative of x cubed is 3x squared, and the y squared tags along, so plus 3x squared y squared. Okay, we need the partial of z with respect to y. Derivative of x squared 0, derivative of minus y cubed minus 3y squared, and then plus, now x is held as a constant, derivative of y squared 2y, so 2x cubed y. And then we need the partial of x with respect to u, and that is just v, because u is a constant, and the partial of y with respect to u, and that's going to be 2u, because this negative v squared is a constant, and its derivative is 0. So therefore the partial of z with respect to u, and I'll go into our formula. Here we have 2x plus 3x squared y squared is partial z with respect to x, now times the partial of x with respect to u, so times v, and then plus partial z with respect to y was the minus 3 y squared plus 2x cubed y, and then times the partial of y with respect to u, which is 2u. And so I could basically leave it that way. I would be satisfied at that point. I mean, if you want to distribute the v, because it did say you could leave your answer in terms of x, y, u, and v. If you want to distribute the v, or maybe just rewrite it as v times this, either order is okay, and then maybe bring the 2x out in front, or the 2u, excuse me, out in front of that quantity. But pretty much either answer I'm going to accept. Okay, so then to the next page, number 14. We'll only do one of these, and then you could practice the other. You're going to find partial z with respect to x implicitly. And so what you have to realize is that z is a function of both x and y. So when we find the partial of z with respect to x, I'm just writing it off to the side because I want to remind myself that z is the dependent and variable and x is the independent variable. So that when I look at the first term, I have a product of x squared and z. And they're both functions of x. And so therefore, we're going to need the product rule. So by the product rule, first factor, x squared, but then the derivative of the second is the derivative of z with respect to x. So that is the partial of z with respect to x. And then we have plus the second factor z, then times the derivative of the first, and the derivative of x squared is just simply 2x. So then we go to the next term, plus, so if you want to make this plus a little thicker, now x is not a factor. So y is going to be treated as a constant, and the derivative of z with respect to x, again, is going to be the partial of z with respect to x. Okay, and then we have the final term. And the derivative of x squared is 2x, y cubed is a constant, so just 2x, y cubed equaling 0. Okay, so I'm sure you're going to see the concept of the product rule come into play. And so at that point, we can, let's see, start cleaning things up. Let me just rewrite this. X squared partial z with respect to x plus 2xz plus y cubed partial z with respect to x, and then plus 2xy cubed equaling 0. So I really didn't do much there. But now we got to solve for partial of z with respect to x. So we'll move everything that contains the partial z with respect to x to one side, everything else to the other. And so we'll have x squared partial z with respect to x plus y cubed partial z with respect to x equaling negative 2xz when transposed, and then minus 2xy cubed when transposed. And the purpose of bringing everything that contains the partial of z with respect to x to one side and everything else to the other, so we can factor out the partial of z with respect to x. So that times x squared plus y cubed on the left is equal to, just recopy what's on the right. And then finally, to solve for the partial of z with respect to x, we just divide both sides by what's in parentheses on the left. So what's on the right is the numerator of a fraction, and what's on the left in parentheses is the denominator of that fraction. Okay, so we'll continue, and the next question is on a directional derivative. So we want to find the directional derivative of f in the direction of u at that given point P. And the formula, you're going to want to write this formula down on your cheat sheet. The formula for the directional derivative, let me actually put it over here. The formula for the directional derivative of the function at a point in the direction of u is equal to the partial of f with respect to x at the point times u1, and the partial of f with respect to y evaluated at that point times u2. But it's important to note that u1 and u2 are the components of the unit vector. And actually this is 3 dimensions, I'm sorry. This is 3 variables. So I've got to add on here, see if I can squeeze this in, a z sub 0, and then this would be plus f sub z, also at the point x sub 0, y sub 0, times u3. And I'm sorry, there needs to be formally z sub 0s in each of these as well. Apologize for that. Okay, so at that point we note that we have the unit vector. So these will be, this is of the form u1i plus u2j plus u3k. And we need 3 partials. I'll skip the functional notation for now. And partial with respect to x, derivative of x cubed, 3x squared. The y squared z tags along. Partial of f with respect to y. Derivative of y squared is 2y, so 2x cubed y and z tag along as constants. And the partial of f with respect to z. And derivative of z is 1, so that's just x cubed y squared, which are the constants. Okay, now we'll evaluate these at the given point. 1, 2, 3 it was. So this is 3 times x is 1 squared, y is 2 squared, z is 3. So f sub x at the point 1, 2, 3 is, what do we get out of that? 9 times 4, 36. For f sub y, at the point 1, 2, 3, 2 times 1 cubed is 1 is x, y is 2, z is 3, and so f sub y at the point 1, 2, 3 is, see, that's looks like 12, and then f sub z evaluated at the point 1, 2, 3. And here we get x is 1 again cubed, y is 2 squared, so it looks like f sub z at the point 1, 2, 3 is just 4. Alright, so now the directional derivative and the direction of u of this function evaluated at the point 1, 2, 3 are just, again, I apologize for the formula here, but this is just f sub x evaluated at the point, so 36 times u1 is the 2/7, then plus f sub y, 12 times u2, which is negative 3/7, and then plus f sub z, which was 4 times u3, which is 6/7. Okay, and then if we crunch that down, what do we get here? 72 minus 36 is 36, plus 24 is 60. So 60 over 7. Okay, now if we go on to number 16, and this is probably, I just wanted to get us warmed up here by going over that one. This is probably more like the one you're going to get on your exam. And it's the same formula, so make sure you write that down. Write it down correctly. Okay, again, I apologize. But we're given a vector A that is not a unit vector. So first, find the unit vector. So make sure you realize in the formula, U1, U2, and U3 are the components of the unit vector. So you have to find that first. And the unit vector is just going to be the vector A divided by its magnitude. So that is 2I minus 3j plus 6k all over magnitude is the square root of the sum of the squares. So 2 squared plus negative 3 squared plus 6 squared. So our unit vector then is 2I minus 3j plus 6k all over, excuse me, the square root of, see, that's 4 and 9 is 13 and 36 is 49. Well, that works out pretty. The square root of 49 is 7. And so our unit vector is 2/7 I minus 3/7 j plus 6/7 k. Alright, so make sure you find the unit vector first, and then it's just a matter of taking the partials once again and evaluating them at the point, and then substituting them into our formula. So for the partials, with respect to x, that'd be 5x to the 4th, and then y to the 6th, z to the 7th tags along. For the partial with respect to y, derivative of y is to the 6th, 6y to the 5th, so 6x to the 5th, y to the 5th, z to the 7th, and then for the partial with respect to z, derivative of z to the 7th, 7z to the 6th, so 7x to the 5th, y to the 6th, z to the 6th, and you really don't have to show this explicitly, but I'm not even going to show the substitutions. Well, maybe I should. It's 5 times 1 to the 4th times 1 to the 6th times 1 to the 7th. But I was going to say that's kind of silly to show that. But if it's not just 1, 1, 1, it's going to make a big difference. So I'm going to show them. So we just get 5. That could have been done by inspection, was the point I'm making. F sub y at 1, 1, 1. Again, being formal. But pretty much by inspection. You can see that's 6. And then for z, I'm just going to say it's 7. Okay, and now plugging into our formula, the directional derivative in the direction of the unit vector of the function f at the point 1, 1, 1 is the partial of f with respect to x at that point, which is 5, times u1, that's their I component, 2/7, plus partial of f with respect to y at the point 6, times coefficient of the j, negative 3/7, and then plus f sub z, which was just 7, times coefficient of k in the unit vector, 6/7. And crunching that down, let's see, we get 10, common denominator 7. So here's 10 minus 18 is negative 8. 42 minus 8 is 34. So 34 over 7. Okay, so definitely one like that where you'll have to find the unit vector first. So I think I'll stop there at this point. We'll come back. Hopefully, just one more part to this review, if not 2 parts. But we'll see you when you're ready.